Hi everybody, we're back for our final two examples of Chapter 4, Lesson 1. The last video we ended with Example 1, if you remember this sheet. That's where we stopped, so we're going to pick up on the back side of this sheet with our notes with Example 2. And we're going to run Example 2 through the same 7 steps that we did from the other side. So we're going to start by finding our critical points. So step 1 is to take the derivative of f prime of x equals 3x squared, and we want to find where the slope of the tangent line is 0, so we're going to set 3x squared equal to 0. Solving for x, we would divide both sides by 3, which will leave that as 0 and this an x squared, and then we'll square root both sides, which is just going to give us x equals 0. That gives us half of our ordered pair. Now we're just going to insert 0 in for x in the original to get the y value. So f of 0 is equal to 0 to the third, which is also 0. So that'll be our y value. So the critical point for this example is 0, 0. Okay, step 2, make the chart. So the second thing we'll do here is we will make our f prime f chart. So we're going to start with f prime of x, underneath that f of x, and a number line. On that number line, we will put the x value from our critical point, which is 0. We will then choose an x value to the left of 0, like -1, and we'll evaluate f prime at that x value. F prime of -1 is 3 times -1 to the second power, which is 3. We just need the sign, which is positive. If I choose an x value to the right of 0, like +1, f prime at +1 would be 3 times 1 squared, which is also 3, also positive. So it looks like the slopes of the tangent lines go from being positive to 0 at our critical point, and then back to positive. So what looks like that? Well, if we increase, level off, and then increase again, which is what f of x would be doing, it would kind of look like this. We would increase till we got to 0 where the slope of the tangent was 0, and then we would increase again. So that's interesting. When we go on to part 3, where they want us to state the type of critical point we have, we actually do not have a critical point. Critical points are defined as maxima, or minima. This point right here is neither, but it does have a name. So even though f of x does not have a critical point, it does have a terrace point. That's what we call this, a terrace point. When your f prime does not change, positive to positive, it could also be negative to negative. That would also indicate a terrace point. So when there's this leveling off, but no change in sign on the derivative, you have a terrace point. So even though f of x does not have a critical point, it does have a terrace point. So we'll leave it at that. We could also say, actually, the way we do in the other examples is a terrace point occurs at 0 since the sign of f prime of x does not change when x equals 0. That'll do it too. Okay, on to step 4. Step 4 is to find our possible inflection point. So we're going to take the second derivative, which is going to be the derivative of f prime, which is going to be 6x. And we're going to go ahead and set that equal to 0, which will result in x equals 0. That's half of the inflection point. To get the y value, we're going to go back to the original, f of x equals x cubed, so f of 0 is going to equal 0 cubed, which is 0. One thing I want to note, when you're finding ordered pairs, you always go back to the original to find the y value. When you're on these charts, that's the only time you're going to be plugging into f prime, or like in the next step I'm going to do f double prime. Okay, step 5. Step 5 is to create the f double prime chart. So I'm going to do f double prime of x, my number line. And onto this chart, I'm going to put the x value of my potential inflection point, 0. Now I'm going to go to the left of 0 to maybe -1, and I'm going to plug -1 into the second derivative. So f double prime of -1, up here, 6x, so 6 times -1 gives me a -6. I just need the sign. And then I'll choose a point to the right of 0, like +1, plug that into the second derivative, and that gives me a +6. So I do have a change in concavity from left to right. This indicates that I'm concave down, and the positive indicates that my graph is concave up. So we definitely have a change there in sign. Okay, step 6 is to find the y-intercept. The y-intercept is just f of 0, and so f of 0 is 0 to the third, which is 0. So the y-intercept is also 0, 0. Okay, so putting this all together now for the graph, what is this all going to look like? Well, it's interesting because the only point we've actually found is 0, 0. So if I'm plotting my graph, I'm going to have a point at 0, 0. That's the only point I have because it ends up being the critical point, the inflection point, and the y-intercept. So all I can do is follow my charts now. So if you look at this first chart here, I know that my slopes go from positive to 0 to positive. So I'm thinking I'm going to increase, my slopes are going to approach 0, and then I'm going to increase again. Now, I do need to check on my concavity. Does my graph that I just sketched go from concave down looking to concave up? I think it does. If you look to the left of 0, we appear to be concave down, and to the right of 0, concave up. And if you think about your studies from earlier courses, this does look like the graph of f of x equals x to the third power. Okay, last example. Another cubic function here. We're going to look at example 3. Let me kind of border this off here so we don't mess up here what's with what. Example 3, f of x equals x to the third minus 12x minus 5. I'm going to run this through my same 7 steps. So step 1, take the derivative, set it equal to 0. So f prime of x equals 3x squared minus 12. Going to set that equal to 0. I'm going to probably add my 12 over here. I'm going to divide by 3 on both sides, and then I'm going to square root. Be careful, that's going to give me plus or minus 2. So I'm actually going to have 2 critical points, one at -2, one at +2. To find the y values that go with these points, I'm going to plug these x values into my function. So I'm just going to actually grab my TI here. I'm going to take, for -2, I'm going to take -2 to the third, minus 12 times -2, minus 5. And that's giving me 11. And then I'll plug +2 in, +2 to the third, minus 12 times 2, minus 5, and that's giving me -21. So I have 2 critical points on my graph, 2 places where the slope of the tangent line will be 0. Okay, step 2 is to make my chart. to figure out the direction of the graph. So step 2, I'm going to do my f prime of x versus f of x chart, number line here. Now I'm going to put two x values on here, so I'm going to actually move from left to right. So I'm going to put -2 and then +2. Now I'm going to choose points to the left, between, and to the right of these values, plug them into f prime of x. Remember, when I'm on the charts, that's when I plug into the derivatives. So let's see, if I take -3 and I plug it into f prime, let's come up here. I can do this in my head. F prime of -3 would be 3 times -3 squared minus 12. That's going to give me +15, so I'm going to go ahead and put a plus there. If I pick a value between -2 and 2, like 0, and plug it into the derivative, 3 times 0 squared minus 12 is going to give me -12. And if I plug +3 up here, I'm also going to get +15. This indicates that the original graph is going to increase, I'll put I for increase, then decrease, and then increase again. So if I was kind of drawing over top of this, this is what the graph is going to do. It's going to increase until it gets to -2. It's going to be 0, the slope will be 0 there. Then it's going to decrease until it gets to +2, at which point the slope will be 0. And then it's going to increase again. So you can see we're going to have two critical points, a maximum and a minimum. And step 3 is going to take care of those statements. So let's go on to step 3. Let's start first with what's happening at -2. It's a maximum. So I'll say a maximum occurs at, and I get the y value when x is -2, so that's going to be 11. Since the sign of f prime of x changes from positive to negative when x is equal to -2. That's my first critical point. Now I'll address what's happening when x is 2. A minimum occurs at -21 since the sign of f prime of x changes from negative to positive when x equals +2. So those are my two statements. Step 4, let's get into inflection points. Second derivative. Second derivative is going to be 6x. I'm going to set that equal to 0. When I divide both sides by 6, I'm going to get x equals 0. So my ordered pair is going to be 0 something. To get that y value, I go all the way back to the original. F of 0 is going to be 0 to the third minus 12 times 0 minus 5, which is just going to give me a simple little -5 there. So this is going to be my potential inflection point. I will test it on my step 5, the chart. I have f double prime of x versus f of x, comparing the two. I'll put my 0 on here. Choosing an x value to the left, like -1, I'm going to feed that into my second derivative. F double prime of -1 is 6 times -1, which is -6. And if I plug +1 in, I'm going to get +6. So there definitely is a change in concavity from being concave down looking to concave up looking. Step 6, my y-intercept is f of 0. If I plug 0 back into my original, I get -5. So it turns out that the y-intercept is the same location as our inflection point. And last but not least, we'll create the graph, step 7. I'll do what I can to fit this on here. It won't be to scale, but we'll do the best we can. So let's see, we have x here, we have f of x here. Here we actually have a couple of good points to plot. So let's start back at the beginning. We've got -2, 11, and 2, -21. So how about if we'll do the x-axis by 1, so 1, 2, 3, 4, 1, 2, 3, 4. But on the y-axis, let's go by 5s. 5, 10, 15, 20, 5, 10, 15, 20. So this will be -5, this will be -20. Okay, so when I go to plot -2, 11, I'll be about here, and then 5, 10, 11. And 2, -21 is going to be down here. So those are my two critical points. I've got my inflection point at 0, -5, which is also my y-intercept. The rest of this, I'm just going to follow my charts. So my F prime chart tells me to increase until I get to -2. So I'm going to increase into -2. Then I'm going to decrease between -2 and +2, being sure to catch the y-intercept. And then as I leave +2, I'm going to increase again. So you can see those slopes of 0 here at my criticals, and you can see the change in concavity here at the inflection point. We go from looking concave down, which is exactly what this sign told me it would, to the left of 0, to concave up, to the right of 0. So that's looking like a pretty decent graph. You can see my slopes are positive, 0, -, 0, positive, which is what this chart says, and my second derivative. So that's all for now. There will be a homework assignment to go with this. Good luck with that, and we'll see you back for the next topic.